So welcome everybody to Azure DevOps with databases in 15 minutes. I love this session because it really enables developers to get their databases in source control and build with all kinds of tests in a matter of minutes. And that is mostly the big problem adopting DevOps, that people think it takes a lot of time. So in this session, we'll talk about Azure DevOps. We're going to talk about Visual Studio. We're going to use Git for our source control, and we're going to use T-SQL-T to do our unit testing. So who am I? I am Sander. I'm a SQL Server DBA living in the Netherlands. I work for Waypoint Analytical, which is a company who does large-scale water, soil, and plant sampling in the United States. I'm a cloud and data center MVP. If you have any questions regarding this session, you can always contact me through Twitter or through my email address. I have a blog which I try to write as much as I can, but yeah, due to all kinds of projects, it tends to be in the background a bit. All the demos will be available on my GitHub page. So under presentations and this session, you can just download the demos and they're free to redistribute, use, change, whatever you want to do with them. With that, I'm also a major contributor to the DBA Tools project. If you haven't heard about DBA Tools and you're a DBA or a developer and want to do more with SQL Server databases, it's a PowerShell module for SQL Server, which helps you with a lot of stuff. So you're going to need tools to get started. So one thing we're going to use is Visual Studio, because we're going to use SQL Server Data Tools, which is an extension and a solution for creating and developing database projects. We're going to use PowerShell to automate a lot of stuff, because I am lazy as it can be when it comes to any repetitive tasks. And we're going to use T-SQL-T to do our unit tests. And in the end, we're going to push everything to Azure DevOps to do our builds. So now we're going to use Visual Studio and SSDT. We're going to create an SSDT project using a template. And that literally takes a couple seconds to do. Then we're going to import the current database schema, and we're going to generate some basic unit tests. What tests are going to be generated? We're going to see object existence, which is important. We're going to see something like, is that store procedure present? Is that table present? Database collation is an important one, because you don't want your database in your development to have a different collation than the one you're actually testing for. Function parameters, did anything change in the function parameters, like the name or the data type? The same thing for procedure parameters. Table columns, did the name or the data type change? Table constraints, index columns, view columns, that's all being generated. And then we're going to go to Azure DevOps, create a project, set up a build pipeline, and then run all the tests for both SQL 2017 and SQL 2019. So let's go to the demos. So I have a little script called create SSDT project. And from now on, I'm actually going to use a stopwatch to show you how fast we can actually achieve this. So when I first started doing anything with database development, I had to create the SSDT solution and then create all the projects inside every time. And I had about 30 databases. And that was a lot of work. So I figured that I could probably use a template. So what I did was I used the PS module development framework that enables you to create templates of files or complete directories, and use replacement variables within those templates to get everything generated. So I did that with an entire solution, and then I have a template, and then I can make this work in a couple seconds. So this entire script actually takes care of downloading the latest version of my template, which is available on my GitHub page. And it will download it, extract it, and the most important part is this little part right here. Invoke PSMD template, which will create the project itself. So I'm going to start my stopwatch. Now I'm going to go to my PowerShell window, and I'm going to run my SSDT project script. It's going to download the latest version, and it's going to install that for you, and done. So let's stop this. This was 25 seconds, and I created a project. So if I open that project, we're going to see a couple things. So it takes a couple seconds to build the first time, loading everything. And I have two projects within my solution. One for the data, which is the data model, it's just short for that, and one for the tests. So next thing I'm going to do is, because I want a demo database, I'm going to create one. And it will do some random creation of a couple tables and store procedures based on random parameters in there. So we have about 50 store procedures and 10 tables. Okay, so let's keep this running because we've got loads of time with this. Let's import the database, select the connection, go to this database because I already did this once. I'm going to change this to object type and going to click start. Okay, it's importing all the objects, done. So now we have the store procedures and the tables that I generated in here. Cool. So the next thing, I'm going to stop the stopwatch because I'm going to explain something. The next script we're going to run is the creation of unit tests. So like I mentioned before, I had a lot of databases and I had a lot of stuff I had to go through. But generating those basic unit tests was a lot of, creating them manually was a lot of work. And they're basically the same. So they only change by the amount of columns that's in a table or the name of the collation that's actually being used. So I can generate that. So as long as there is a repetitive thing going, I can automate it. So I made the PST-SQLT test generator, which is also available on my GitHub page, but you can also download it from the PowerShell gallery. So it's in the PowerShell gallery, and you can just do install module PST-SQLT test generator, and it will install it for you. And the only thing you have to do is point it to an instance with a database and then say, okay, that's the output. In this case, I'm going to output directly to my just created SSDT solution. So let's run that script. I'm going to start the stopwatch again. So clear the screen a bit because there's going to be a lot of stuff going on. So it's going to connect to the database and it's going to get that state, and based on that, create the unit tests. I want to emphasize, do not run this every time for your CI/CD because it takes the state of that current database. And if you rerun this every time, your tests will always be successful. So this is only meant to be run when you first initialize the project, just to get you started. So let's look at the files because they're being generated right here. And just to show you, we are at 2 minutes and 16 seconds. And it takes by generating about 120 tests, something like that. So 2.5 minutes in, and we have our unit tests. So let's import those. into our solution, existing item, test basic, select everything, and add. Yes, it's all in there. So let's stop the stopwatch. And we are still below 3 minutes. I just want to show you a couple of these tests just to emphasize how easy and how clear those are. So one of the tests that's being generated is, does my object exist? Which is mind-blowing that you actually need this, but imagine a developer removing an object by accident, pushing that to your source control, and suddenly you don't have that object anymore. So in T-SQL-T, we can do an assert object exists, and then this is the name of the object, and it will check if it exists. Another one is the one that we can use that does it have the correct parameters? So what it does, it creates an actual table, just a temporary one and an expected one, then inserts what's being expected and then acts upon that. So it inserts the values based on this table and then asserts these tables. That's it. That's actually what's happening within that script. And that is how the other scripts kind of work. They do similar things based on templates. So that is basic unit testing. Integration testing goes a lot further than this, but this just gets you started. So now we have our solution, but we have to put this in source control. So I'm going to go to my directory. So let's do that one. And then this one is called unit testing. And as you can see, I don't have anything with Git in here. And we are going to use Git as our source control. So I'm going to do Git init, which initializes the directory, the entire Git repository. Then we're going to do Git add, and then with the dot, we add everything. The next thing we're going to do is add commit everything with a message initial commit. This can be any message, but this is just how I initialize those. So now I have my repository. Let's go to Azure DevOps. I'm going to create a new project called unit testing. And for this reason, I'm going to make it a public one and done. So I'm going to create my project. This takes a couple seconds. Yes, there we are. Now we're going to go to our repos and I'm going to copy this piece of code. I'm going to push an existing repository from the command line. Paste the code in. Done. So now if I refresh the data, I have everything in here, which is good. Now we want to put in a pipeline. So with the generated solution, I also create an Azure Pipelines YAML file for you, which is all taken care of with the correct names and everything. So I'm going to pause this for a second and we're going to go through this. What it's going to do is it has a stage for the build where it will build the solution, copy the files to an artifact directory, and then publish the artifact because I want to use that artifact later on in another operating system. This is all Windows-based. This is a Windows-based image, but the next one is going to be the stage test with two jobs. It's going to have a Linux 2017 job and a, where is it? And a Linux 2019 job. Yeah, here it is. So here's my other job, Linux 2019. And they're basically the same. The only thing that's different is Docker image that I'm using. So in each of these jobs, I declare a couple variables, and then I'm going to do some prerequisites from a file. Then I'm going to download the artifacts that I had from the previous stage. Then I'm going to install SQL package, which is used to deploy the DAC pack, which is the result from our SSDT solution. Then I'm going to start the SQL Server container, and I'm going to publish the DAC pack, and then I'm going to run all the tsqlt tests. And the same thing for the SQL Server 2019 version. So let's start the stopwatch again. And I am going to say run. So let's go to the build because we want to see what's happening. And we are still 5 minutes, so we're going to make this. Come on, start. Sometimes it takes a couple seconds. Yes, there we go. So checking out the Git repository, then I am going to get everything build, which takes a couple seconds still, maybe half a minute. Build started. And I'm actually saying this has to be a release, which is part of our YAML file, which I declared, what I wanted to do. Okay. Building. I think Azure is a bit busy today because it usually runs a little faster than this. Just creating the model. There we go. And the model.xml, which is the entire model of the database, is something that's being used to deploy everything at the end. So a DAC pack, which is being generated, is like a fancy zip file with all the scripts needed to execute. So that's what is in there. So it's taken a minute, 27 seconds. It's going to publish the artifact. And then it's going to finalize the job. And now we're going to test for SQL Server 2019 and SQL Server 2017. Keep in mind that this is only a Docker image. So you can change this to any image that you want, as long as it's a running Docker image for SQL Server. You can change it to any CU or anything you want, and it will still run. So if you have a different version for your entire street for the test, acceptance, or production, just change that in the variables and you're good to go. So we're going to install a couple of prerequisites that we use in the scripting. So it's going to use DBA tools, which we use to publish the DAC pack. Yes, there we go. Downloading the artifacts. We're going to install SQL package, which is important because otherwise we cannot do anything. It's going to start the SQL Server container, and it's actually downloading the latest version from the mcr.microsoft.com. So this is all taken into account that that image is not on the image that I'm using to run this job. Okay, it's almost done. Let's see what we are on time. Well, we are still way behind, way up to schedule. So we're going to do the deployment. And after the deployment, it's going to run the tests. And remember, we had like 120 tests. Let's see how long it takes to do that. So publishing DACpack normally takes about 30 seconds, something like that. Yes, there we go. It's going to run the tests. Yes, publish the test results and done. So now we have both tests for SQL Server 2017 and 2019 within 10 minutes. And in previous tries, I actually got that to be below 8 minutes. And I'm not sure why it ran a little slower today. Maybe my internet connection wasn't that fast and everything, but I was actually being able to do this almost 2 minutes faster than this. So let's look what we can do more with that. So we can go back. Whoa, not there. We want to see the test result. Did it change? So this was the entire pipeline that we used. We pushed everything to our repo, and from now on, any change that is pushed to your repository will be tested in this way. So one thing you have to take into account that any object that you create after this should have those object existence tests and those table tests and everything. But you now have a method to get all your databases into source control within 15 minutes. So let's go back to the slides. So the tools we used were Visual Studio, which is a free tool. We used the PS module development PowerShell module. We used a template that can be used with the PS module development module, and we used the PST/SQLT test generator. I want to thank you for watching this session, and hopefully you can implement these practices in your environment. If you have any questions, you know how to reach me, and I look forward to your questions if you have any. Thank you.